Okay, we're going to look at some logarithm properties, and what is interesting and nice about the logarithm properties are they're very similar to the power properties, because remember, logarithms mean that we're talking about the exponents. Okay, so for example, if you see this where we have x to a power times x to another power, what do we do with the exponents? We add the exponents. So we're multiplying the powers and then we're adding the exponents. So very similar with logs, if you have log base b of x plus log base b of y, it's the same thing as combining them as log base b of x times y, right? So you multiply that argument and that argument together, right? So if you're adding the logs, it's the same as multiplying the arguments together if the bases are the same, right? So now if I slide over here, and you notice that I have x to the a divided by x to the b, what do? We subtract the power. So very similar here, okay, if the logs are the same, so log base b of x minus log base b of y is the same as log base b of x divided by y. So we can divide that and combine it under one logarithm, okay? And probably the most important, the most useful rule is the following rule right here. If I have x to the a raised to the b, right, what do I do with the powers? I multiply, okay? So x times log base b of y, what I can do is I can move that to the top and write x to the log base b of x to the y power, okay? And we have this nice emoji here, which we like to think about is, look, if you have a power up here, okay, you can move it down to the front, and then you got a logarithm right there. Okay, so this is probably the most important one out of all of them. We're going to use it to solve quite a bit. Okay, so let's take a look at a couple of examples, and it's easiest to deal with the exponents first. Okay, so first of all, if I see this exponent, I'm going to move it up to the top. If I see this 3, I'm going to move it up to the top. Okay, so I can rewrite this as common log of a to the d minus common log of c to the third. All right, so that's the first thing that I'm going to do. And then I can recognize that I'm subtracting two logs with the same base. The base is 10 here because it's a common log. So what I can say is now I can combine them under one common log. And I can say a raised to the d power divided by c to the third. And now I've combined them, I've condensed them into one logarithm. Okay? All right, let's look at this next example. Deal with the exponents first. I've got a 2 in the front. I'm going to move it up top. I've got a y in the front. I'm going to move it up top. So I'm going to write log base b of c. So log of c to the second power plus log of d to the yth power. Okay, so now if you notice here, I'm adding two logs with the same base. So I can combine them. I can say under one log, I can say this is the same as c squared times d to the y power. Okay, so you can see how that's following very similar rules as your exponent rules when addition and multiplication are related. Okay, now we look at this next video. Okay, notice I've got the same base. I've got a 2 in the front, move it up. All right, and there's nothing I can really do here, so I'm not going to do anything to that 8 because there's no number in the front here. Okay, so I'm going to write log base b of 4 squared now plus log base b of 8. And now that you notice that if I'm dealing with numbers here, you want to go ahead and evaluate out those numbers, right? So what I've got here is 4 squared, so I'm going to write log base b of 16 plus log base b of 8. And now I can combine both of those terms and say this is the same as log base b of 16 times 8 is 128. Okay, so it's the same thing, right? Now we go ahead and take a look at this right here. Notice now I'm dealing all with numbers, so I'm going to slide that 5 up to the top, slide this 2 up to the top so it becomes an exponent. So I'd say log base b of 2 to the 5th power minus log base b of 4 to the 2nd power, okay? So now I'll just rewrite this real quick to make sure that we're clear here. 2 to the 5th would be 32 minus log base b of 4 squared is 16, right? So now I've got log base b of 32 divided by 16, which is the same as log base b of 2, okay? So you can see that we're just kind of combining these into one logarithm, okay? All right, now for the aspire to do here, similar thing, right? I'm gonna move the 1/2 up front, okay? And now I got this to deal with, all right? So I'm gonna move that log base b to the front, so log base b of 4 to the 1/2 power plus log base b of this. Now, I'm gonna rewrite this as 2 to the 3rd, and now I've got to understand that the cubed root becomes the denominator in a fraction, okay? So now I'll simplify here, and I'll say that log base b of the square root of 4 is 2, plus log base b, that should be a b, of 2 to the 3 over 3 is 2. And now I combine it under one logarithm. Log base b of 2 times 2 is 4. Okay? And then another aspire to do, again, dealing with these fractional exponents right here. I'm going to take my 5/2. I'm going to move it up to the top here. So I'm going to get log base b of 4 to the 5 halves minus log base b of 1/2. Okay, so what I'm going to do here is I'm going to evaluate this in my calculator, and what I could say here is the square root of 4 is 2, so I could say log base b of 2, and I still got the 5 to deal with, minus log base b of 2 to the -1, okay? All right, so now what I'm dealing with here is division. So I've got log base b of 32 minus log base b of 2 to the -1, or you could say 1/2. So now I've got log base b of 32 divided by 1/2, okay? Now keep, change, flip, and I've got log base b of 64, okay? Next things, expanding exponents, okay? So if we deal with the exponents last in this particular case, okay? So now what I'm recognizing here is I've got log of 8 times x to the 5th, so let's separate that. So I've got log of 8 plus log of x raised to the 5th power. And now I can drag this exponent down to the front. So I'm going to say log base b of 8 plus 5 log of x. All right, moving on to this next one right here. Now you've got to be careful with division here because we're dividing that whole thing by that whole thing. Okay, so watch what I'm going to do here. I'm going to say, well, we're taking the log of 4 plus the log of y to the 3rd. And now we're dividing by, so I subtract, we're dividing by this entire thing. So log of x minus log of z squared, right? Because this entire base you're dividing by. Okay, and then I'm going to simplify it. Okay, so log of 4 plus, bring that down to the front, 3 log of y. Now distribute through, so I've got minus log of x plus, bring this 2 down to the front, 2 log of z. And that's it. That's completely expanded. Okay? All right, now last one for expire to do. What happens if the log of a equals a number, the log of b equals a number, and the log of c equals a number? Let's kind of figure out what this is. All right, the first weird thing that I'm going to deal with is, what is this again? So let's rewrite this as c to the 3 divided by 2. Okay, so what I'm going to write is the following. I'm going to say log of c to the, instead of using the radical notation, I'm going to use a fractional notation. And then remember, I'm dividing by this whole thing. All right, so I would say log of a to the second power, okay, plus log of b to the third power. Okay, and now I'm going to move it down to the front. So I'm going to say 3/2 log base c minus 2 log of a, and then this just gets distributed in here, minus 3 log of b. And then there you go for the aspire to do. And just to double check, I'm pretty sure I made a mistake right up here. And the mistake right up here is that x times yz should be plus, because you're multiplying those two things together, right? So right down here, we're going to change this to a minus 2 log z. All right? Okay. Hope you all have a positive rest of your day.